Shh. I will have you talk muchly soon. Just a second. Okay. Procedural announcement. I had a big brain moment. Something that will save me 6, 7 hours of time. You're welcome. And my son is still tormenting me with it. I'm still going to do it to you guys because I am basically 9 years old. Anyway, I had a big brain moment in the 3 o'clock class, and unless anyone can see if this is, like a bad idea for some reason, I'm going to do it. I don't like entering 249 higher of the two scores modifying grade books. I make mistakes that way. You shouldn't want me to manually enter grades either because I make mistakes and that's bad. So instead of opening a second copy of Homework 5 and manually copying in the higher of your two grades, I propose the following. That's what I offered last week, right? Right? Monday? Whatever. What I propose is the following. I make a new Homework 5 and I say I will drop the two lowest homeworks from your grade. That way, if you got the problems you wanted on homework 5 right, you don't have to do it, and then the new one will be dropped. If you want to redo it, then you get the higher score on the redo, the homework 5 retake, second time, whatever, and you get the higher score on that, and the other one is dropped. Does that sound copacetic, happy, ethical, fair? Great, that's what we're doing. Also, homework 6, what the hell? You could redo homework 6 too. I'm going to put 5, 6 together, put 5 and 6 together and say that'll be your homework for this week. There was the stupid question that I announced before about it leaked through from last year, the homework about the that had drag in the problem. It's not supposed to be there. That'll be taken out, but otherwise homework 5 and 6 will be smushed together. It'll be a 5-6 redo. It is optional if you got the grade you wanted on the 5-6, ignore it. But I will say it's good practice for the midterm. I will also hint, does anybody not take lab at West? One person. Okay, there's a couple people here. I am going to upload. I have given this week's lab exercise for the West lab people is midterm review. Thank you. Midterm review, and I want everyone to have access to that. And it's very similar to last year's midterm. Hint, hint, hint. Which, as you saw for midterm 1, is very similar to this year's midterm. I modify it a bit so they can't just memorize stuff. But yeah, hint, hint, hint. I'm going to post this in the files section of our what's it? I will try to remember to send out an announcement. This will be done no later than tomorrow afternoon. I strongly encourage you, if you're doing stuff in the lab, ignore it. If you are not in the lab section, this is a wink, wink, good way to study. The questions are half of the test is these questions slightly modified. I will say also, reminder, I announced this, I think I announced this to this section as well. I hope I announced this. Last midterm 1 went too fast. Most people were done in like 30 minutes. When there are too many questions and people are running out of time, that's bad. I don't want to do that. But the fewer questions there are, the worse it is for a grade if you make one innocent mistake. So I'm bumping it up to 25 questions. I don't think that should be too difficult. I also don't think that, I also think that'll be helpful. It's weighted the same. It'll be where 75, whatever the midterm 1 was weighted, the same weight for this one. Question? Oh, thumbs up, good. Okay, I think that's all of the administrative notes before we do physics. Oh, last administrative note is I decided based on where the 3 o'clock was, and I'm glad that I did. I'm going to try to insert spring force in insert spring force in when we do energy at the end of the semester. Springs are good, springs are great, springs are not even that hard, but I'd rather you do a few things well than a whole bunch of things poorly. And based on what I was saying with the 3 o'clock section, spending this time on friction, I feel they made breakthroughs, and I was very pleased with where we went. So no springs for you on this test. Just friction, normal, weight, and tension. I think that's all of the administrative things. Any questions about next week, the midterm? Yeah. Those are deletable. I'm sorry. It's because I copied over. I'm going to go through and freaking make sure that they all hide. I'm sorry. Don't trust the homeworks until I properly announce them. Don't trust the homeworks until I say that they're ready in class. The homework redo, the 5-6 redo will be this week's homework. Yeah. Yeah. That's where I take the test questions from. Gently modified versions of the concepts on quizzes and stuffs. Yeah. There will be nothing new. I mean, like maybe a conceptual question or a state the equation for do you know what weight is equation might be something that you haven't seen, but like anything that you're crunching on, anything that's any difficulty should be. You have all seen them all before in a slightly modified version. Question? No. Classes. Okay. Any other thoughts? Yeah. Always. But a half sheet for the midterm. You'll get a full sheet for the midterm, for the final. I mean, whole sheet one side, half sheet both sides. I don't care. Good. It's good. It'll be just the same as midterm one, except yeah. Okay, let's dive in. I was very pleased with where I saw the 3 o'clock go. It made me very happy. I want to see you guys do the same. Or better, or show them up. So what we're going to do here is I've got a problem. Oh, I have so many problems. I've got a problem that involves multiple pieces, and we're going to build up from simple to hard, demonstrating the same damn techniques we've always done, analyzing the same different way. And this problem will involve the various equations that you need for everything we're ever doing on midterm 2. And where I see people getting confused, where I see people stuck, that's what we'll that's what we'll discuss. So follow along. Here's the problem statement. It's not a bad idea to take a picture or screenshot this on Zoom or whatever. Here's the problem statement. I'll describe what's going on here. There's a truck with an unsecured cardboard box in the back. The truck is moving initially to the right at 10 meters per second, but it's braking at negative, spoilers, it's braking with a magnitude of 3 meters per second squared, and the direction is leftward for the acceleration. If you're slowing down while moving right, it's negative acceleration, right? Okay, I'm going to give you the mass of the road underneath the truck is 10,000 kilos. The mass of the box is 100 kilos. The mass of the truck is 1,500 kilos. I'm going to give you the static friction and kinetic friction coefficients for the box truck interface and for the truck road interface. Yes, I'm giving you more than you need to do the problem because I want you to think critically about what you need, what it means, and not just take numbers that look good and guess the operation. You have to actually think about what does it mean in the equations you've got. Okay, so any questions about the problem statement? Write down all the numbers, sketch it real fast. Take a picture, whatever. Here are the first 3 questions. Google question A. Suppose we stay static. Suppose we stay the box is moving along with slowing down at the same rate as the truck. Find the static friction force. Vector, include a plus minus sign as appropriate. Case B, what if we are sliding? If the box is in motion relative to the truck, if they're not slowing down at the same rate, if the box is going to be smacking into the tail, what do you call that? Tailgate. Find the kinetic friction vector. And finally, I ask you, is it actually going to be static or kinetic? Is the static friction force magnitude less than the maximum that it can provide? This is a yes or no question, yeah? Okay, I'm going to give you 15 minutes by the clock. Please turn to your neighbor. Please do this together. You may begin. Oh, hey, so that I can grade automatically, I finally got that working. So that I can check you automatically for this entire day, let's round G to 10, okay? For a uniform thing. Everybody round G to 10 for today so that I can check answers automatically. Anyway, I'm only giving you one sig fig almost anywhere here. So it should be rounded to 10. Is good? Round to 10. Round G to 10. Continue. Gina, will answer be submitted individually, or all three get submitted on individual forms? Here is question A. Here's question B. Here's question C. Just like we've been doing, put them in, hit submit, then hit edit response. You can enter them as you go, or you can enter them all together. I don't care. It's fine either way. Very interesting. That's what S and K mean. And it's not moving, it's sliding over or sticking to. It's moving regardless. All these cases, there's motion. Is there motion between the surfaces? You'll need that for C. There is no equation for static friction. You have to use other laws. What's the only other law that you know about? There is only one force, so that force is F net. No, means acceleration is -3. It's moving, what I said is it's moving with the truck. If acceleration is 0, then it's going to freeze in place and the truck is, if it's stuck to the truck, then it is moving with the truck. If the truck is accelerating at -3 meters per second, so is the box. Of the truck on the box. I mean, friction force of a thing, any force of a thing doesn't exist. Force is an interaction between two things. The force that the truck exerts on the box. Yes. Maybe I should write that specifically. FSTB. My auto grader skips it, but the correct way to specify is number space unit. Yeah. Interesting. Interesting. Muy interesting. Oh, for God's sake. I can't type. What are we taking G for, yo? What's G? 10, y'all. Follow directions.
So for this or A, would that be f of s is equal to MA, so that would be 100 times -3. And
Good.
with B, when you're looking for friction force on it,
Which friction? There are two frictions. A was F of S, B is F of K.
you say f of k.
Yeah, that's what I asked.
So then for f of k, oh yes, right there. For f of k, that would equal that's mu, right? That's what you say. Mu with the 100 kilograms times gravity, which is 10 in this case.
Good.
That comes out to 300 or something like that.
Which mu applies for kinetic case.
So it would be the 0.5 times 100 times 10 equals.
Not 300. 500.
Oh, yeah, sorry.
Which direction is that friction force? Which direction is that friction?
Negative. So
Box is slowing down while moving
that
forward.
would be negative.
Negative 500 is correct.
Okay, so it would be 0.5 times 100 times 10 negative, so that would be, because that comes out to, I guess, 500.
Negative 500. Yeah. Good.
And then for, if the box is f of s is less than f of s max, that would be no, right? Because f of s is 300.
No.
No?
F of S. Well, sorry, go on. I interrupted.
First part in f max would be, I believe, 8.
Yeah, so F of S 300 is less than F of S max
sorry.
800.
Okay.
Good.
Thank you.
Good.
Is it asking, or the answer we got for A is greater or lesser than this one? Because that's a different thing and I'm not. Quite.
So to find static friction, there is no single equation.
Yep.
You have to use other equations. What's the only other equation that you know? That applies for everything.
Wait, the max one or the,
But you know it's not max. I told you it's not max. It's only one other equation that we're using this chapter.
that is the.
Huh? F net equals,
The forces vertically or,
and there's only one.
yeah,
So F net equals, what's the punchline?
sorry, repeat the question,
The punchline, F net equals always. F net equals
there.
vertically zero. We're accelerating horizontally. If you're sticking with the truck and the truck's slowing down, MA, net force is MA, always.
That's all. I'll track my notes again.
I'm gonna do it in a minute. I'm gonna talk through it.
For example, the big job apple is of course
So like F net,
Good.
it can
First
be
one, yes.
so like
No, you can't have both at the same time.
so will one of them should be in the opposite direction. Can I keep F
It's not
kinetic?
one of them. There's either kinetic or static. It's either slipping or it's not slipping. You can't be both slipping and not slipping. You gotta choose one. Is it static or is it kinetic? Part A, I'm saying is it if it's static, how do we do it? Part B is if it's kinetic, how do we do it?
But like if we have to find the static friction, we need to find a way to connect it to F net, right?
And
So
what is the F net if it's static? What forces make up the horizontal force?
The-
Yeah, is there any other force acting horizontally?
no,
Exactly. So F net is F static, is MA. You did that right. First part's good. Dos minutos.
think it's just number there. Without the syllabus that was required, I think that's next. Yeah. This slide was just but that one you have to be there to do anything. I think that's the last section. I think like everyone showed you.
One minute.
I'm related. I'm related. My sister's wife.
And time's up. Put in your answers. Let me scan it. Let my software scan it because I'm so smart I can grade automatically now. Whoa! And so many people have A correct. Fewer people have B correct, curiously enough. Most of you all got A's sign correct. Almost everybody got B's sign wrongo. Okay, so let's talk about this. Reason through this. Here is the export solution. Static friction has no force equation. You must always find static friction based on reasoning. The only other equation that you know that applies always and forever is net force equals ma. Now, there are two things to this. There's the F and there's the A. First off, you have to recognize that the net force on this object is the static friction force. There is no other horizontal thing acting. Do you see that? There is nothing else acting on this box to slow it down other than static friction. Yeah. You'd be wrong. I'm sorry, I interrupted. Say more. We're going to have in 20 minutes, 30 minutes, something with two horizontal forces, and it won't make it impossible. We'll see how. But you, in that case, can't just say that static friction is equal to ma. You have to say that static friction is part of total, which is equal to ma. Good question. Yes. Sorry for interrupting. Okay. So idea one, F equals ma, and if static friction is the only horizontal force, then static friction is the net force. What's acceleration of the box? -3. There's thinking here too. I said it stays in place on the truck. It moves with the truck. As the truck moves, there moves the box. The truck and the box are moving together. Hint, 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 hint at the beginning, right? So if the truck and the box are stuck, the truck is stuck, then the acceleration of the truck equals the acceleration of the box. You have to recognize that as well. Otherwise, it's undoable. You can't use that equation. So F net equals F static friction. F static friction equals ma, negative 300 newtons. Negative 300 newtons. I asked for the direction as well. Which direction is the box accelerating? Leftamundo. Which direction is the static friction force? Leftamundo. The static friction vector is left. F net equals ma is something that everyone should have deeply internalized now. I'm saying that net force is static friction, is FSTB, is what I asked. Static friction is the only horizontal force, therefore it is the net. Okay, if static friction is the net force, then we could say static friction equals ma. M 100, A -3. I gave you that. For the box. Yeah. Yeah. Good. Other questions? No? Okay. So that's static friction. Remember this technique because it's how you'll solve everything with static friction. I mean, half of the pieces recognizing what acceleration is and building up the net force applies to more than just friction problems. Remember that too. Problem B, can we use F equals ma? Do you know the acceleration if the box is slipping? No. Now, you'll be able to find it, but you don't know it to start with, so you can't use F box equals ma, kinetic equals ma. So what other formulas do we know might apply here? Mu k n, mu k times n. What's mu k? Given. What's n? Normal force. What is the normal force on this box? It's equal to its weight. Is normal always equal to weight? No. Why? Think through it. Why logically must normal equal weight in this case? There are two vertical forces, not no, but they have to balance. Exactly. Normal up, weight down. They can't be, they have to be equal magnitudes or one would win and the box would accelerate. Right? Net force has to be 0. F equals ma vertically has to be 0. Hey, why don't we say normal minus weight equals m times -3? Why isn't the acceleration for normal minus weight -3? Why did I just say normal minus weight is 0? I thought acceleration is -3. The box is not accelerating in the vertical direction. A is -3 tells you the horizontal velocity, the acceleration. Exactly. That's what he said. Vertical and horizontal are different directions. You have to consider, is the box shooting off into outer space? Phasing through the truck into the ground? No. It's not accelerating up, down. Therefore, normal and weight are balanced. Don't just write down normal minus weight equals ma and say, oh, a equals 3, -3. You have to think about what a means. I mean, that's the general theme of everything in physics. You have to think about what it means or you're screwed. Question? Yes.
Why can't we use the formula mu s?
Because that's not the formula for static friction. That is not what mu Sn tells you. Mu Sn does not tell you the value of static friction. What does mu Sn tell you? The maximum that you can get out of static friction. To find out the value of static friction, you must always use other principles. Good. Other questions? I like it. A, -300. B, mu k times normal, mu k times m times g is -500. Very few people got the negative sign. Let's reason about this. Which direction is the box accelerating as it slides across? Think about it, leftward is the answer. Think about it this way. Think about it this way. If there were an icy surface, you cover the truck bed in ice and then you butter the truck bed, butter the ice, and then you put olive oil on top of that, and then you put some rosemary and garlic. And, never mind. Sorry, that's how you make truck bed saute. No, suppose you reduce friction to 0. No friction on the truck bed. What's going to happen to the box? Where's the box going to go? The truck slows down. Without friction, the box is going to continue. It's going to smack into the truck cab, the front of the truck, right? Now, it's not in real life frictionless. What is friction going to do? It's going to try to prevent what would happen without friction. It opposes the approaching the cab direction. Friction points left, kinetic and static. Again, think through this. Here's how to logic out, always logic out which direction friction points. Imagine if there were no friction, what would happen? Friction, real friction, opposes that result. Without friction, it would smack into the cab. What opposes smacking into the cab? Left friction. No, you don't like that. You really don't like that. No, you don't like that at all. Okay. Step 1, does it make sense? Does it make sense? Are you sure? Do you agree? Am I convincing you? Do you buy that it would hit the cab instead of the tailgate? Who thinks it'll hit the cab? Not just because I told you. Who feels it in your bones that if there's no friction, the truck brakes, the box smacks the cab? You really buy it? The front, the back of the driver's head. Who thinks that the box, the truck slams on the brakes, there's no friction, it slaps into the back of the truck? If there's no friction, well, I'm asking, there are a couple of pieces in figuring out the direction of friction. Most people got this wrong, so I'm logicking through, figuring out where y'all are confuzzled. about, I think half of you said you feel in your heart of hearts, intuitively, your intuition is correct, that without friction, the truck brakes, the box slides into the front of the truck, right? What's really happening is the truck is slowing down around the box. Who thinks, who feels, who intuits that if the truck brakes, the box goes back to the back of the truck. Okay. So let me follow this up by saying, which direction do you go if you gun it in the truck? Which direction do you feel flung? Do you feel flung forward when you gun the engine? Don't you hit the back seat? If you are accelerating forward, you are pushed into the back seat. You're not actually pushed into the back seat. The back seat is pushing into you. Car is accelerating around you. Okay, so if you're accelerating forward, you smack into the back of the car. If you are braking, which direction do you lurch? Forward, right? That's what's happening to the box. If the truck is braking, the truck is slowing down around the box. Without friction, then the box can't go backwards. Yeah. If there were no friction, it would go forwards. I'm showing you how to logic out to find which way it always goes. I'm not saying that it does go forwards. In this case, the direction of friction is leftward. The direction of friction is leftward. That's what we're reasoning to. Whether the box smacks into the front or back of the truck bed, that we could discover later. That's separate. That's not what we're talking about now. Right now, my only goal is to help everybody understand which direction. How can you always find out what friction does, even in the hardest problem? Yeah.
Imagine if there was no friction.
Right. That's my
And the truck
trick.
driver is applying brakes.
Mm-hmm.
Automatically go to the back of the driver.
No. The back of the driver. Yes. Yes. Right. So if there's no friction, the box slams into the driver's back, slams into the box is what's really happening.
Yeah. So now let's consider a case where there is friction.
Friction will oppose that.
Yeah, and since the direction of the box would be right, the direction of the friction would be left.
That's correct. That's what I'm trying to teach. Exactly. You've got it. One more time, here's how to reason about this, always and forever. Imagine what would happen without friction. Friction acts in the opposite direction of that. Yeah. The force on the box is leftward. I'm not saying that the acceleration of the box relative to the car is left. Maybe it is. I don't know. I haven't worked it out yet. I don't think so. I think actually relative to the car, the car slows down faster than the box slows down, and it does end up there. But first you have to reason about what direction is the force on the box before you can find anything else out. And how you do it is you imagine there's no friction. Friction opposes that. The force of friction opposes that. You still don't like that? Ask me. Great, let's hear it. It is. It's accelerating left. It's moving right. The truck is moving right and slowing down, accelerating left. But velocity has nothing to do with it. I put velocity in as a red herring. Velocity is irrelevant to forces, only acceleration. You can't say the truck is moving, the velocity is right, therefore the friction is left. Talk to me. Yes, Absolutely. Are you okay with the magnitude 500 for B? Really? Truly? Yes? Okay. So 500 mu k n. Then the direction, again, here's how to find the direction of friction always. Can you tell me which direction would the box go relative to the truck? Which side of the truck would it smack if there were no friction? If you take friction force away, where does the box end up hitting? Yeah. And what's really happening there is without any forces on the box, it's not that the box is pushed forward. The box isn't pushed at all in our imagination without friction. What's happening is that the car is slowing down, the back of the driver is being accelerated into the box. I want to emphasize that, by the way. If when you hit the brakes, there is nothing pushing you forward. The car is slowing down around you. The seat belt is pushing on you backwards to slow your inertia. That's what's happening in a braking car. So I want to be precise and not give a misconception when I say the box isn't moving forward. Well, the box isn't accelerating forward. The box has no forward force. The car around the box is slowing down so that the box does smack into the driver. Yes. The magnitude? The 500 part, not the minus part. Great. So talk to me about the equation for kinetic friction always. What equation did I present last time? That's a true statement, but that's not the equation for Fk. Mu k times n, yes. That's the equation for static friction. Do you know how to find normal, n? Yeah. Okay, so what's the weight of this box? Yeah, no, 1,000, 1,000. 100 kilos times 10 for g is 1,000. You're right about that. Okay, what's the other part for static friction, kinetic friction magnitude? Mu k. Static coefficient. Kinetic coefficient. What is the kinetic coefficient? Okay, this symbol means coefficient of friction. If there's a subscript s, that's the static coefficient. If there's a subscript k, there's a kinetic coefficient. Now, I listed multiple values to make you think about it. Yes, y 0.5. Why is it that top right one? Yeah. And how do you know it's the right one instead of the left one? Yeah. Mu. Mu is how you would transliterate that in English. Yes. Good. 500. Magnitude. Talk to me.
It's negative 500.
Yes. Friction is leftward on this box. If there were no leftward friction, it would continue as it was and smack into the cab. Yeah.
Negative or positive depending on the direction that's going.
The direction of motion is irrelevant. The velocity is not important. It's all about the acceleration. Forces don't know about velocity. Forces don't care about velocity. F equals ma, force and acceleration are linked. So the velocity is 10 meters per second is utterly irrelevant. That said, let's talk about the pieces again. Without friction, which side of the truck smacks into the box? Okay, so with friction, which opposes that front? Exactly. You got it. That's it. That's the entire concept. Good. Yeah. Yeah. If the box is sliding, it is not accelerating at the same rate as the truck. because those are vertical. Vertical direction is not the horizontal direction. Gravity doesn't push you left, right. And in this case, static friction doesn't push you up, down. The acceleration is 0 vertically because the box isn't shooting up. Box isn't falling down. Vertical acceleration is 0. So the up force balances the down force. Normal still equals weight in either case or case B. One's up, down, one's left, right. What do you mean? Because I'm saying the truck is braking as it's coming to a halt. So I presume that you know that cars brake not up, down. I mean, if the car goes down, it'll brake in a different way. Now, I have not done, this is not being taught at a trig-based level. With a trigonometry-based physics class, we would introduce subscripts and say this is acceleration in the x direction, a subscript x. Acceleration in the y direction would be a subscript y. But sine and cosine would kill people here, so we're leaving that out for this semester, so I'm not having those subscripts. I'm just having you reason about it, thinking about up, down, left, right. Last chance for questions. Yes. Nope. I mean, I can't think of a way that they could be different, but I don't want you to rely on that. There is no physical law that says that, and I don't know if that'll always be true. So I encourage you to think about it this way. Which way would it happen without friction? Friction opposes that. Great. Now we move on. Negative 300, negative 500. And how do we calculate Fs max for C? Mu Sn. Exactly. Mu S times normal. And what's normal? In this case, weight. So 1,000 kilos, right? The 1,000 newtons. So what's the max friction force? Max static is 800. 0.8 times 1,000 times 0.8 times 100 times 10. Okay, so max is 800. What did we calculate it needs to be for realsies? If I take it off the vector sign, so we're talking magnitudes here, 300. Is 300 less than 800? Yes. What does it mean? What is always true if static friction is providing less than its max? What can you conclude? What's actually happening? Not that it's not moving, it's not sliding, it's not skidding, it's not moving over relative to the surface. How I describe that is it is sticking to the surface. Right? You haven't broken static friction. Still moving together. How do you feel about this? There are steps here, and these steps must be put in place. But if you get these steps, these aren't just for friction problems. If you iron out your misconceptions here, like the people who were asking the questions and working through it, guess what? You're going to do way better on the midterm. You're going to understand this stuff. It gets better. Let's go on to the next part. Now I'm going to make it hard. What's D? What's D? Where did I put D? What? What's D? What? Oh, for God's sake, I forget what D is. Okay, now we're going to assume that, whoa, I don't want to show that to you. We're going to assume that we say stuck. Okay, let's say it stays in static condition, which, I mean, it does, right? We showed that static friction only need provide 300 out of 800 total possible. So let's say that we stay static. list the force triplets acting on the truck. I will give you a hint. Just about everybody screwed this up in the 3 o'clock section. I think it was like 15% got it right. So please check your work carefully. Talk to your neighbor. Make sure that you are considering everything that is acting on the truck. Also, despite the fact that we've been doing this for almost a month, I still have 10% of the 3 o'clock section is not telling me in the correct notation. Oh my God, turn to your neighbor, and if they're telling single letters, please, no, don't commit violence, but please tell them to write it properly and guide them through understanding. Aiden, yeah, I forgot what I asked D in the 3 o'clock section, and I want the things to be lining up. So skip D. Skip D. Okay. So. You good? For E, list the force triplets acting on the truck. And because I have realized that throwing alphabetization at people screws everything up, you may enter it in any order. You do not need to alphabetize. Merry Christmas. Just give me a comma-separated list of the triplet notation forces acting on the truck. Is good? What you're doing? This time you have 2 minutes. You may still work together. Ugh.
I think. Unless it, he said it was right. Yeah. Yeah, I remember. Yeah, I thought. Yeah, and then the group that must have just. I don't remember it as my. Yeah. I don't remember what the money like, but I don't know. I know. We like the. Where did we connect from? Yes, there was the doctor on. Yes. Just be static. Static friction. Not the bottom. And I think the road truck, yeah, the road truck is the thing.
That's what the triplet is, always. Aiden, always dealer feeler. Okay, I've got a whole bunch of people putting answers in D. D for donut. I asked you to put this in E. That's why I put an E there. Please move your things over to E. Make this easy for me to grade.
Well, I thought at first do that fighting in it. But I didn't.
After the comments, we put a space.
Oh, I mean, it doesn't matter. I have to hand grade those.
It would be box on the truck, normal force, right?
No, the first letter is not the dealer. The first letter is the type. NBT.
okay.
NRT.
NBT,
WET.
WBT.
Yeah.
and that's
Type
right.
dealer feeler.
Type dealer.
Yeah. Type dealer feeler. Always. Time's up. Okay. Still got 10% of y'all not typing the format correctly. Please, please, please listen. The format, when I say triplet notation, means you type the type letter. For instance, for weight, what letter is weight? W. You type the dealer of the force. What object causes weight force? What object causes weight? Earth, E. What object feels the weight in this case? T. So the triplet notation is not gravity. It is not W. It is WET. Okay? Okay. That said, the correct answers are here. There are 4 lights, but there are 5 forces, if you know that mean. 5. Count them, baby.
We had all of them.
Because that's what driving and walking is. That's because it's rolling. Rolling smoothly over a surface is not skidding over that surface. There might be movement, but it's not back and forth movement. It's rolling over. There can be kinetic friction if you're leaving tread marks. But remember this, if you're just running around, if you're not doing a Kramer, if you're not leaving a skid mark, it is static. Question? I mean, I would have given credit either way, but here's how I'm uniformly going to write this. If I'm distinguishing static from kinetic, I'm going to write the subscript in addition to. The subscript is part of the F letter for me. No, what I'm just asking is for people to write letters. So W-E-T. Yeah. Or in this case, like F-S-B-T, whatever. I would have given full credit for F-B-T though. Yeah. Nope, because we are not doing drag. Arizona's too conservative. Yes. Because driving and walking are always static friction. If you're skidding, if you're Kramering, if you're leaving tire tracks, tread marks, that's kinetic friction. But rolling, walking smoothly over a surface, you might be moving, but the surface of your foot as you move over the surface is not going back and forth along the surface. The surface of the bottom of the wheel is not skidding along the surface. Write this down and memorize this if you need. Driving normally, walking normally is static friction. You only get kinetic friction if you're skidding, leaving tread marks, sliding. I mean, if you are skidding, leaving tread marks, cars these days have something called ABS, anti-lock brake systems, to prevent skidding because skidding doesn't actually work as well. But if I do not say skidding to a stop, you can assume driving normally, you can assume it is static. If I do not include specific words about skidding, leaving a tread mark, sliding, yeah. We will discover when we do what? We will discover when we do circular motion that a wheel rolling along, the middle of the wheel moves at the velocity of the whole wheel. The top of the wheel has a velocity twice the velocity of the total, and the velocity of the bottom is 0. Velocity of the bottom of a wheel that is rolling along is not actually moving relative to the surface. We'll get there, hopefully. Okay, so NRT, FSRT. Did you get that? The road frictions the truck as well. Hopefully everyone got NRT. What about friction of road on truck? Question first.
Friction, makes sense. Do we just do S?
I don't mind either way. I will tell you FSRT, FKRT, whatever, but for your answering things, if you just type FRT, I would still give that credit.
Is S okay as well, just to base static?
No, because S is going to be spring force later.
Well, shots.
Yeah. S stands for shocks. There we go, too. And FKK stands for, I don't know, corn force or whatever. The band, not the vegetable. Okay, anyway, moving on. A fair number of people drop the static friction of the road. How do you know the road has to be slowing? I gave it away. How do you know the road has to be frictioning the truck? The truck is slowing down. If there were no friction of the road, how could you brake? You'd be sliding along a frictionless surface. You can't change your motion. Okay, what about normal force of box on truck? Who dropped that? Well, yeah, it's downward, but what I'm saying is who forgot that it exists. Newton's third law, baby. Normal force of box on truck, no friction force of box on truck. If the truck pushes the box has to push the truck. Same force, opposite direction. Same magnitude, opposite direction. Don't forget. Wet. You good with wet? I know it's rare in Arizona. Hey! Because it's so dry here? Whatever. I'm just being silly. Okay, now I want to see if you can reason about up, down, left, right. And for the sake of grading uniformity, I don't want you to tell me up, down, left, right. Please do not type positive, negative. Please do not type plus, minus. Please do type plus if it's up or right, or minus if it's down or left for each of these forces. Question? What kind of friction is rolling friction? For us in here, I'm calling that static friction. Now, you know a little bit more. You've done this before. That's axles. Rolling friction doesn't actually have to do with the tire and the road. I'm teaching people about the external forces acting on it. You're right, there's actually also a third kind of thing, but we're not, this is hard enough already. You know too much. Okay, Gina, can I repeat the format of how you answer this question? Plus sign or minus sign for each of these? Just a plus or a minus. And again, this goes in F, G, H, I, and J, respectively. That's why I boxed those letters in front. All right, can you do it? Oh my God, please help each other answer the question in the term shown. Huh. Huh. All I want is a plus sign or a minus sign, yo. Actually, all I want is to see a giant woman, but that's different.
Oh, wait, never mind that.
Yeah.
Oh, wait. It's not right. Oh.
Hey, HL Vaughn, L Nunez Ma, Ian Contreras already. You're not hitting enter for these guys. I haven't gotten a single response. No, I have. Never mind. Ignore me. Carry on. Carry on, my wayward sons. You just haven't done this one. I didn't do it. What? What do you want? No, it's not. It's braking to a halt. BRAKE.
Yeah. Okay. That's what I was. There we go.
Okay, we're just about out of time. We only got 10 minutes left. The correcto answer's O. The road pushes up on the truck. Just about everyone got that right. Good. The weight force of the earth on the truck. I'm very glad to see that most people remember that gravity pulls things down. Most people remember that. The static friction of the road on the truck. Let's read about this. Which direction is the truck accelerating? Left. Truck is slowing down. Don't confuse velocity for acceleration. So there must be a leftward force. It's braking. We've been talking about the whole time. Now, what about the friction force of the box on the truck? Nope. Yep. Why? Friction, not normal. Which direction does the box feel the force? We spent like 15 minutes on this. Box feels friction's leftward. Negative 300, negative 500 newtons, yeah? So if the box feels pushed left, which direction does the truck feel from the box? And normal force of the box on the truck, let me count that. No, that's not what I wanted to be as well. Okay, normal force. Here, silly example that I came up with on the fly for the 3 o'clock class. Everybody here probably routinely goes to either be Santa at the mall or sit on Santa's lap, right? That's a universal experience. You guys don't act as Santa? No? You guys don't put on the beard and the red hat? I thought you guys are all mall Santas. Okay. Well, whatever. You've heard of mall Santas. You've heard of people sitting on other people's laps, right? Suppose you are the box. Suppose you are somebody sitting on Santa's lap. Do you not feel a support force on your booty pushing you upward? Right? The normal force on the box is upward. It is supporting you. It is pressing upward on your booty. If you are Santa, if you are Santa, hell, or if you're Satan, having someone sit on your lap, do you feel pulled up into the sky by their butt on your leg? No, the top of your leg is being pushed down, right? So if the top of your leg is pushed down, you, the truck, the Santa, feel a negative force. And anyway, again, what we did before, normal force of truck on box is up. Newton's third law says it has to be down. Oh, I want to do one more. I want to do one more. I want to do one more, but you guys do not want to do one more. We'll pick this up on Monday. Get out of here. I mean, it's only 5 minutes. Don't give me too much credit. Wait, let me hit stop.